Section 6.3 Interactive Assignment Objective 2. The number of hits to a website follows a Poisson process. Hits occur at the rate of 1.4 per minute between 7 p.m. and 10 p.m. Given below are three scenarios for the number of hits to the website. We want to compute the probability of each scenario between 7:49 p.m. and 7:53 p.m. and we're going to interpret each result. So we want to find exactly 5, fewer than 5, and at least 5. Okay, so if a random variable x follows a Poisson process, we can use the following probability rule to compute Poisson probabilities. We have the following formula: p of x, which is equal to the lambda times t to the power of x over x factorial times e to the power of negative lambda times t, where x can be equal to 0, 1, 2, 3, and so on, where lambda represents the average number of occurrences of the event, meaning the mean, in some interval of length 1, and the value of e is approximately 2.71828. Now, t represents the particular time that we're dealing with. So in this example, we can see here that lambda is going to represent the value of 1.4. So there is lambda. And then we also know that t is going to represent the time between 7:49 p.m. and 7:53 p.m. So t is going to represent that value. So if we take 7:53 and subtract 7:49, we get the value of 4. So therefore t is going to equal 4. Okay, now when we want to find the probability of exactly 5, we're going to use this formula. Okay, so looking at this formula, what does each represent? Well, we know that lambda represents 1.4. Okay, we know the value of t represents 4. And since we're looking for exactly 5, we know that the value of x is going to be 5. Okay, so now we need to plug this into our formula, so we need to work order of operations. So if we take 1.4 and multiply it by 4 and raise it to the 5th power, so let's go ahead and do that on a calculator. So we have parentheses 1.4 times 4, and then we're going to raise that to the power of 5. Then that gives us the following, and that's going to be our numerator. Okay, and then we know that 5 factorial, if we want to find 5 factorial, we're going to write down 5, we're going to go to math, and then scroll to the right where it says probability, and then go down to number 4 for the factorial symbol, and 5 factorial is 120. So now if we take the following value, and then which is the numerator, and then divide that by 120, which is what we have in the denominator, and then we're going to take this value and we're going to multiply it by e to the power of negative 5.6. So we're going to say times second with the value of e raised to the power of negative 5.6, since negative 1.4 times 4 is negative 5.6, and then that gives us the following value. So we get 0.169710921, and then rounding that to 4 decimal places gives us 0.1697. Now, if we want to write that as a fraction rounding to 2 decimal places, we would round this to 0.17, which then equals 17 over 100. So in order to interpret this, we would say on about 17 of every 100 time intervals between 7:49 p.m. and 7:53 p.m., the website will receive exactly 5 hits. So going back to our answer here, you can see that we have the following. Let me go back to the result of part A, 0.1697. And again, on about 17 of every 100 intervals, we can see it gives us the following result. Now we need to find fewer than 5. Okay, now to find fewer than 5, we have to calculate the probability of less than 5 occurrences. by calculating the sum of the probabilities of all occurrences values that are less than 5. Okay, so here we know that the probability of x being less than 5 is equal to the probability of x being less than or equal to 4, which means we need to find the probability of exactly 0 plus the probability of exactly 1 plus the probability of exactly 2 plus the probability of exactly 3 plus the probability of exactly 4. Okay, and then what we're going to do is we're going to plug each value in. So we already know that lambda, and what lambda represents, is 1.4. So we know that that's 1.4 for lambda. For each particular formula, we know that lambda is our value of 1.4. Okay, and then we also know that t represents 4. So we know that t represents 4. So we have 4 in each of our formulas for each individual one. Okay, now we need to find out, okay, the exact amount. Well, the exact amount being 0. So this is going to be 0 factorial and then to the power of 0 here. Okay, when it's exactly 1, it's 1 factorial and then 1 there. When it's exactly 2, you have 2 factorial and that's to the power of 2. When it's 3 factorial, we have the value of 3 and then 3 there. And then when it's exactly 4, we have 4 and then 4. So each of these is going to give us a probability of exactly of that particular number. So when we evaluate that, we can do the following in a step-by-step process. Anything to the 0 power is 1 and 0 factorial is 1. So this is 1 over 1 times e to the negative 5.6. 1.4 times 4 to the power of 1 is 5.6 over 1 times e to the negative 5.6 plus 31.36 over 2 times e to the negative 5.6. That gives us the second one over here because this is squared. And over here, raised to the third power gives us the following over 6 because 3 factorial is equal to 6 times e to the negative 5.6 plus over here in the numerator we get 983.4496 divided by 24 times e to the negative 5.6. So what we need to do is we need to figure out each individual value and then we're going to add them together. So let's just quickly do that here on our calculator. Okay, so our first one is 1 times, again, e to the negative 5.6. And so there's our first value. And the next one we have 5.6, and that's going to be times e to the negative 5.6. Go back, make sure we put that number in there. 5.6. And that gives us 0.0207080. And then over here in parentheses, just so that you can follow along here, we got 31.36. We divide that by 2, and then parentheses, and then we're going to multiply that by e to the negative 5.6, and that gives us 0.0579825. And then doing the next one, we have 175.616, and then divide that by the value of 6, and then we're going to multiply that by e to the negative 5.6. So using parentheses is really important here, and here we get that value, and then the last one, left parenthesis 983.4496, and then divide that by 24. And then we're multiplying that by e to the negative 5.6, and that gives us 0.1512768. So therefore, now when we add up all these values, then we get 0.34215, and then we're going to round that to 4 decimal places. Rounding it to 4 decimal places gives us 0.3422. Okay. And so keep in mind here that if we wanted to round this to 2 decimal places, it would be 0.34, which would then equal 34 over 100. So we would say that on about 34 of every 100 time intervals between 7:49 p.m. and 7:53 p.m., the website will receive fewer than 5 hits. Okay, so let's go back to our result here, and we can see that we got 0.3422, and on about 34 you can see it's fewer than 5 hits. Okay, now we want to find at least 5. So going to at least 5, we always use the complement rule to obtain the value for an at least probability for a Poisson process. So at least is the same thing as saying x is greater than or equal to 5. Well, the complement of x is greater than or equal to 5 is x being less than 5. So we want to find the probability where it's 1 minus the probability of x being less than 5. Well, we found that in the previous example. X less than 5 gave us the probability of 0.3422. So we're going to have 0.3422, and we're going to take 1 and subtract that value. When we subtract that value, we get 0.6578. So that is the probability. Now if we run it to 2 decimal places, this would give us 0.66, which then would be 66 over 100. And then we would say that on about 66 of every 100 time intervals between 7:49 p.m. and 7:53 p.m., the website will receive at least 5 hits. And then going back to our question, we will see that our result is 0.6578, and there is our answer for the interpretation.